All right, good morning. Today we want to look at the variation in the properties of some elements, and we're still on periodic table year 11. And during the course of this class, they want us to explain the periodicity of some elements and to actually look at the chemical reactivities of these elements. Okay, so when we say periodicity, what is periodicity? So periodicity is actually a reoccurrence of some phenomena at intervals. Okay, and this phenomena are the thermal and electrical conductivities of these elements. It can be their melting point and boiling point. It can be their electronegativity. It can be their electropositivity. It can be their ionization energy, electron affinity, the ionic radius or radii, and the atomic radii. Okay, these are the variation in their physical properties. All right, so let's pick the boiling point and the melting point. Now, the boiling point and the melting point of your non-metals, then the group decreases, and then across the period it increases for non-metals. Okay, but for metals, the boiling point and the melting point down the group actually increases. Okay, but across the period it decreases. Okay, now let's look at thermal and electrical conductivity. Now, for the thermal and electrical conductivity across the period, it decreases. Now, why? Because it tends to move from metal to non-metal, and as we know, our metal have high thermal and electrical conductivity. So as you go across the period, it decreases, yes, and down the group it increases. Okay, so let's also look at their electron affinity. So when we say electron affinity, we're saying those elements that love electrons. So affinity, you love something, love for something. Okay, so let's pick nitrogen, oxygen, and fluorine. Okay, so when you look at this, your fluorine will need, let's draw this the configuration 2 5 2 6 and 2 7. So your chlorine will need 3, right? To complete 8. Your oxygen will need 2 to complete 8. Your fluorine will need 1 to complete 8. So we're saying that our nitrogen will love electron the most. So we're saying as you move from your left to right, what happens to your electron affinity? Your electron affinity decreases across the period, and down the group it increases. Okay, all right, so let's look at electronegativity. So for electronegativity, we can see that it increases across the period. Why? Because the table is moving from metals to non-metals. Are we good? All right, it's moving from metals to non-metals. You can see that. Okay, from group 1 to groups 0. Okay, from metals to non-metals. So what happens to their electronegativity? What happens to it? It increases, because your group 7 are highly electronegative than your group 6. Okay, group 6 are highly electronegative than group 5. Okay, your group 5 are highly electronegative than group 4. So when you're going across the period, your electronegativity increases. Okay, and down the group, electronegativity decreases. Okay, so we're looking at electropositivity. When you're going across the group, it decreases. Electropositivity across the group, it decreases. Across the period, it decreases, and down the group it increases. Okay, now when you look at your atomic radii or atomic radius and ionic radius, we're saying that across the period it decreases and down the group it increases. Why? Because as the number of shell increases, oh, did I say shell? As the number of electron increases, okay, as the number of electron increases, it tends to shrink. Let's pick example, the group 1, the period, let's pick period 2. So we have hydrogen, helium, okay, lithium 2 1, beryllium 2 2, boron 2 3. Let's pick, that is, they're all in period 2. So let's pick the group 1, group 1 down. Okay, the group 1 down, let's say lithium is 2 1, sodium is 2 8 1, potassium is 2 8 8 1. Okay, now as the shell increases, as you're trying to draw the shell, you will notice what happened is as the shell is increasing, it's getting bigger, right? So the radius too will be getting bigger and bigger and bigger. So you're saying down the group it increases. Are we good? Now, but across the period, the shell is still the same. Now what increases is the electron. So as you have plenty electron, the effect of those electrons now shrinks the shell, which leads to a decrease in the radius of this element. Okay, so that would be that about the physical properties. Now let's look at their chemical properties now. So for the chemical properties, we said that elements in the same group tend to resemble one another in their chemical behavior. Yes, they resemble one another in the chemical in their chemical behavior because they have the same number of electrons in their atomos shell, which we call the valence electron. The valence electron is the number of electrons in their atomos shell. So all group 1 chemically they actually behave the same way. Okay, the group 1 are actually called the alkaline metals, and they are very, very reactive. Yes, they are very, very reactive, and they form stable compounds. Yes, they form stable compounds, and they are called univalency. Yes, they are called univalency because they tend to lose one electron and they become positive. Okay, so like you have Na plus, Ca2 plus. So they lose when you say 2 plus, it means loss of what? 2 electrons to become positive. Then the group 2 are called alkaline earth metals. They are called divalency, or they are divalent because they lose how many electrons? 2 electrons. They lose 2 electrons. Then the group 7 are called the halogens. The group 7 are called the halogens because they will accept electron. How many? 1. So they're actually negative, minus. They are minus. Okay, so you see Cl minus, F minus, O2 minus. So O2 minus is telling you that oxygen has accepted 2 electrons. Oxygen has accepted 2 electrons to complete its shell, while the group 8 are actually called the noble gas, or you call them the inert gas, or you call them the rare gas, or you call them the rare gases. Sorry, the noble gases, the rare gases, the inert gases, or you call them the non-reactive gases. Why? Because their shell is complete. It's either doublet or that it is complete. So they are not fighting with anybody. They are not begging. They are not dragging. They are just there, and they are always colorless. Yes, they are always colorless, and they are monoatomic in nature. Okay, so when we also look at the group, like we explained, between the group 2 and group 3, we said we have the transition metals. Okay, So these transition metals, what are the properties? They are metallic in nature. Yes, they are metallic in nature, but they have high tensile strength. They have very high tensile strength, unlike the other metals. They have high melting and boiling point. Their melting and boiling point is not here. They have high melting and boiling point. They have variable valences, or we call them variable oxidation number. So like iron can be plus, it can be 2 plus, it can be 3 plus. Copper can be Cu plus, Cu2 plus, but most times it's always Cu2 plus. We are used to Cu2 plus, and for iron we are used to Fe2 plus and Fe3 plus, the green and the brown color. Okay, then they also act as catalyst, like your nickel. Like, yes, your nickel is a very good catalyst, and or well known one as that. They also form complex ions. Okay, they form complex ions, the transition metals, and they are commercially important. Yes, the transition metals are commercially important. Okay, and your rare gases, sorry, your rare element, that is your lactinides. Okay, and your lactinides resembles each other a lot. Your lactinides resembles each other a whole lot, and then they are rare gases. They are rare elements. I like gas. I like noble gases, but they are rare elements. All right. Okay. So let's just call it a day for now. Next class we will look at types of chemical reaction. All right. So thank you so much, and then see you next class. Have a wonderful weekend. Bye.